spend just a couple of minutes, if I can, please, running through the progress that we've made on topology and inventory services, a new function we introduced in the last release, and just to do a quick demo as well on a cool feature that we added recently. Okay, so these are just in the slides that I'll make available later. These links might be useful for you, but just to give you a quick rundown on the coordinates for the project. So my name is John Keeney from Ericsson Software Technology. I'm the PTL of the non-RTVIC project, but this work is actually happening in the SMO project. So SESU is the PTL there. I've added wiki links, all the different links that you will need to get there, including the weekly meeting that Alex and I hold together, which is probably the best place to talk about this, or at the bi-weekly SMO project meeting. So a very quick summary of what it is that we're trying to do and why are we doing it is the ORAN has defined Topology Exposure and Inventory Service, SMOS, as part of the SMO, so SMOS SMO service. And its northbound interface is being defined to be part of the R1 interface, so that our apps can access just enough information to get an overview of the topology of the RAN, and I think eventually more than just the RAN, but initially the RAN, and it would draw kind of topology related information from lots of other sources of truth within the SMO. The idea being to provide an abstracted or simplified view, and if you want more information than that, you should retrieve it from the actual source of truth. Okay, so as I mentioned, the idea is to allow our apps to have just enough topology information, and then if they need more, go get it. Okay. In particular, importance is that it's a consolidated cross-domain summary. If we were to take just topology-related information from a single domain, that would kind of dictate the information that's defined or given and the format of it. Whereas this is a cross-domain summary, so we've a little bit more freedom in terms of what the model for that data would be. So in Workgroup 10, in our alliance there, the format for these data models is being defined, and this API is also being defined. In addition to that, we would also like to be able to allow our apps or users to add their own information about the topology information. So the idea is to augment the topology data or to group topology entities, which you probably would not be able to do back in the original source of truth for the data that informed that topology view. Okay. So the goal here in OSD is to create an open source implementation of this, and with the view to supporting the work that's happening in ORAN Alliance to specify the topology and inventory, topology exposure and inventory function, the APIs and the models. We'd also like people, if possible, to start using this thing so they get a feeling for the pros and cons of the existing work around topology exposure, and also to help drive forward any improvements that might be needed in the specifications. We also think that it's a particularly useful feature for our apps to be able to get this abstracted view. So I think it's an important enabling feature for our apps and R1 in general. Okay, right, so where are we at then? So first release, very first early release came out in July as part of the J release, and a much improved version came out just before the Christmas there in the K release. Okay. So let's talk for a little bit about the API. Again, the API doc is available here at this link at the bottom of the screen. I'm just going to give you a very quick overview of the types of things that the API provide. So the data in TIV is arranged into domains. So the first call here is to get the list of domains. Then within the topology data, with the topology data model, we have the concept of entities, which are typed, and relationships, which are typed. Relationships can be intra-domain. So within a single domain, you can have relationships between entities in a single domain, and also cross-domain relationships. All relationships are typed. We also, the internal model for defining the data is Yang. So we provide some support here for schemas and the contents of the schemas describing the data. I also mentioned that we could decorate the data based on some keywords, or classify the data based on the values for entities and their relationships. And we can also group either statically entities, or we can also dynamically group entities by giving them a query that essentially acts as the group membership query. So I mentioned the models, and in particular, I mentioned domains, which kind of separates the data sources from the types of things into different domains. So currently, this implementation, we have 4 domains, and then I describe different inter-domain relationships as well. So if I just very briefly flick over these, and again, bearing in mind that this information, including the actual YANG files that defines each of these domains and relationships, is available here online. Okay, so the RAN domain is probably the most complicated, and it describes some of the key features or entity types that you might expect in a RAN topology model, but it's much simpler than the configuration, the O1CM view of the RAN domain. So we introduced some of the key functions here, or the key entities, and some relationships, intra-RAN relationships. So for instance, the relationship between an NRCell CU is provided by an OCU CP function, okay, just as an example, right? So you'll see we also define here each of the attributes for each of the entities. Okay. Then for the equipment domain, so it's kind of focusing more on RAN equipment, but also can be extended out to other types of equipment. So we have the concept of a site and an antenna module installed at that site. Okay, we would envisage that this model will explode out as work continues in workgroup 10 to either for this domain or for something similar. Okay, we also have an OAM domain, which is handy for being able to associate managed element. The different entities to find the managed element responsible for those. We also have a cloud domain, where we have some of the key concepts that you might want to describe for cloud-related topology. Okay. But probably more interesting is the cross-domain relationships. So, for example, we have a couple of relationships here defined across both the equipment and the RAN domain. Like, for instance, that a sector is grouped by antenna modules, that the antenna capabilities are cell use is served by antenna module, for example. This one is probably most interesting to some of you, which actually links the OEM domain to the RAN domain. So allows you to figure out what is the managed element responsible for each of these. We also have the cloud to RAN, which tells us which NF deployment serves which of these RAN functions. OEM to cloud then similarly. Okay. It gives you this link between a deployment, a managed element, and a cloudified NF. This is the big picture overall, with everything all merged in together. This model is still very immature and still being actively developed at least in our open source version. Like, for instance, we're trying to figure out how to actually capture the ORAN logical view of a RAN, for example, the O1 links, the A1 relationship. In fact, the SMO isn't defined as an entity here at all. So we're working on trying to extend that in our open source version of the model. But we're also making sure that the models that we use are constantly related back to the models that are starting to emerge in Workgroup 10. So making sure that we keep a good sync between our open source proposed models and the actual specified and standardized models from Workgroup 10. So just to demo this, I want to have just a very brief demo scenario where a user wants to get the list of antenna modules within a given geographical area, say for instance in Manhattan. For some reason, they're only interested in the electrical tilt values for those antenna modules. One example of why that might be is, for instance, as part of a localized load balancing optimization use case, or some of those use cases that we used to refer to as SON, but are now, I suppose, lumped under generic kind of ORAP-based optimization functions. The user might also want to perform this query fairly often, so maybe create a group for this as opposed to having to specify the full query every time, or indeed to have another advantage of, if you've your role-based access control set up correctly, you could assign this to a group and then assign a particular role to just that group query, for example. Okay, so that you would have a restricted amount of querying capability. Also, we want this to be a dynamic group, so that if something changes in the RAN deployment, that gets eventually mirrored through into the topology view of the RAN, and that also then is dynamically updated in the group view. Okay, and maybe we would like to have different groups for different geographical areas. So I am now going to hand over to Jeff, who will walk you through the different steps involved here. This is quite an easy, simple use case, so this should only take a minute or so. So please bear with us. So please, Jeff, will you take the share?
Yeah. Can you see my screen there?
Yes.
Okay, cool.
I'm not sure yet. I think you're still seeing my screen.
Okay.
Yes, now.
Yeah. Okay, cool. Yeah. So here's the example of the this is the antenna module here. You can see there's a bunch of attributes there: the electronical antenna tilt and the geolocation. Here's again antenna module and the electronic antenna tilt. And this is some of these are two of the entities that we're going to be adding here. This one here is the Empire State Building, the electronical antenna tilt, and the geolocation. And the one under here is the Manhattan Bridge, there with the electronical antenna tilt and the geolocation. And here we can see it plotted on the map, Empire State Building them there, and the Manhattan Bridge. Okay. So here is the query in TNIV. So as you can see here, we have the attributes covered by geolocation, and then the polygon we want to search or query. And here it is, URL encoded. So we send that off there. And you can see here that we get the antenna module for the Empire State Building. And that would look something. That's the polygon that we're searching. And then this is the Empire State Building, and that's the Manhattan Bridge. As you can see, it's not included in the polygon there. So we go back to TNIV and we change that there. So now it covers, let's see, this polygon here. We search that, and we can see we get two antenna modules back, Empire State Building and Manhattan Bridge there. Now we can create queries for that, or groups for that. As you can see here, we have a group. This is for the smaller polygon there. As you can see, we created the group and we get an ID back. With this one, yeah, as you can see, that's the only difference there. So that's the bigger polygon there, and we get an ID back for that. And here we can then query the members of this group. This is the ID we got from the group there. It's group 1. And as you can see, that's just the same. It's the same with this one as well. See, this is for the big polygon, this is for the small polygon. And now if we add two more entities in, we'll add the Flatiron Building and the Brooklyn Bridge. So send that in there. And now, yeah, so now we're going to be querying. We have all four of these entities on the map when we query. And now when we query group 1 again, this is the small polygon, we should see two entities here, and we do. So we see something like this on the map, where the Empire State Building and the Flatiron are included in the polygon. You can see the Brooklyn Bridge and Manhattan Bridge aren't. And then when we query the group of this group, the bigger polygon, we can see we get all 4 entities there, and it would look similar to this on the map. Yeah, that's pretty much it. You can take that over again there, John.
Okay, good. I'm aware now that we're running very tight on time, so I'll be as quick as I can. So if, press share. Okay. So in the slide deck that I have available, I'll give more detail of the actual queries that were used here, how to rerun this demo yourself, and for instance, how to define, for instance, the shape that you might want to do a geographical query on. It's part of what's called a WKT, a well-known text format for defining shapes in geographical systems. We also, with the example of the query, you'll see how we were able to restrict the query to just return the antenna tilt value as opposed to the entire entry for the entities. We show how the filter was defined to, that we were only interested in antenna modules. We also show the filter then for the geographical location. Let me just very, very, very briefly pop up one of the queries here. So this is the query, for instance, to get the smaller polygon with just one thing result. So the domain is equipment, the entity type is antenna module, the target filter, which tells us which parts that we want back. We only want antenna tilt back. And then the scope belt gives essentially a query for how to filter the results that we get back. So here we show we're essentially passing in a polygon here that defines this shape here. So that's why we only get one result back for the first example. And then there's, in the other slides, then you'll see that there's plenty of examples of how we define the group, how we query the group, and the results that we expect to get back. So let me now please. Okay, so again, this is the same example.
Can you wrap it up if possible?
Yes, I'm wrapping up now, right now. So for this release, we plan to continue to develop and improve the topology functions, particularly improving tooling, documentation, testing, models, those kind of things. But one thing that we really want to make a push on over the next few months is integrating with other open source activities, particularly in OSC, to try populate this data, because we need adapters to populate the topology information from these sources of truth. So we're hoping over the next couple of releases to bombard you with use cases where we're able to demonstrate integrations and use of the topology functions. Okay, so in addition, all at the same time, keeping abreast with and where we can even helping the specification activities in Workgroup 10. So I'm going to wrap up now. I know I have blown through my question time, but Martin might indulge you for a moment if you have anything that you would like to ask.
Is there one question from the audience? Otherwise, I would like to highlight that Jinri is also bringing this to TSC attention, that here this activity is really in parallel from the open source development and the specification. Yeah, so I think that's the first time where this really goes in parallel.
And I'd like to advise you, please, to chat with Sandeep. He's driving the topology work in Workgroup 10 as part of the specification activity, and he'll be able to attest to how easy it is to work together where we have an open source version and the specification developing and maturing in parallel. It makes life so much easier on both sides where we get this right, where we do the joint specification and joint open source together. Thank you.
Yeah. No, thank you very much, Jeff and John. Very impressive work. Also, all the details, how you can query and using here geographical polygons. Very nice.
Thank you.